All right, we are live now.
Yeah, hello everyone. Welcome to today's session with AI Planet. I'm thrilled to announce our esteemed speaker Vishwas Narayan, who is joining us today as a deep learning.ai ambassador. Vishwas has a deep understanding of Docker and Kubernetes as well. He plays a vital role in advocating the adoption of cutting-edge technologies within the data science community. It is very evident from his own YouTube channel, where he has hosted a number of sessions with industry experts on diverse topics on technology. You should definitely go and watch that. Today, Vishwas will be delivering an insightful session on the topic Docker and Kubernetes for data scientists. With no further ado, I invite you all to join me in giving a warm virtual welcome to Vishwas Narayanan. And let's dive into the session on Docker and Kubernetes for technologies that will enhance the way data science workflows happen. And over to you, Vishwas. Thank you.
Sure. I think thank you so much, folks. AI is never going to be a problem statement of just writing an ML code because that is something that I'll be explaining. ML code is just a tiny part of it, but there's a lot of things that goes behind from labeling your data set to training your model, testing your model in a real at that scale where at that scale ka matlab, I'm just saying about how many words that you can type per second. That's the amount of GB that probably you might start ingesting over a course of time. Like, let's say you write not per second, like at least for a minute. Like, let's say you can write 60 words a minute max. That's absolutely fine. Probably there is a system that is actually ingesting 60 GBs of data a second. That means you are writing a lot of data, you are creating a lot of data in a similar fashion. A lot of people are creating data out there. So right now, if you just go out there and look at what is the stat of data that is there, it's in zettabytes. That's 10 to the power of 21. That's huge. That's humongous, right? So I'll just share my screen so that I can start with a little intro that can really give you an introduction about why I'm talking about Kubernetes, why isn't there a requirement of Kubernetes or Docker? This is just part one. I think part two, part three, I'll just be coming up with some more series where I'll be explaining you beyond the entire production line or anything like that. So I think you just have to stay tuned for that. That's it. So that's the whole point. I think I'm sharing my screen. I think it's time to turn it on. I think I've shared my screen. I think you have to just put it on the stream right now. So yes, so let me just do a slideshow. So there are different model to it, right? Software development didn't start with just coding. It also evolved with respect to methodologies. So there are different models to it. So waterfall, agile, DevOps, Scrum, all these things always come back to application architecture, application infrastructure, deployment, and package. This is just a simple understanding that I'm giving to you. All the things that you're doing right now, let's say this is a MacBook Pro right now, and it has its own set of compute engine that is already designed for me. And if you consider all these other aspects that I'm talking right now, there's a lot that you can do with Kubernetes, CI, Docker, whatever it is. So in a similar fashion, what happens in your real world from a developer environment to the operations? That means making sure everything works fine happens within these three elements, physical, virtual, and cloud. These are the cloud combinations that you have right now. So typical development process always starts with one thing. It's either you really go out there, figure out, okay, this is something that I want to do, and this is something that I want to really put in terms of an efforts, and this is something that I'm going to code. And there's only one tool called as GitHub today that's going to affect you in order to make sure that you effectively utilize the entire compute engines and everything. So, what happens in your typical day to day life as a software engineer or as anybody who's just talking about DevOps or deep learning, machine learning, whatever it is? Code, build, test, release, deploy, operate on the entire process. That means every code, build, test, release, deploy has to be monitored, has to be made sure that it happens at one given point of time. Then monitor the application, monitor the infrastructure, then you have to plan accordingly. So there's a lot of challenge that goes behind. So Docker Hub is always about build, ship, run the application. It's absolutely amazing at that scale. What's happening is very simple. Whatever I just explained you here will also happen the same way here. So what you do is build, ship some code, you test it on different cloud like virtual cloud and physical servers which you have on your system. And still, what happens is at the end of the day, you still start running your applications. There are different environments that always create, okay, this is something that I want to start using in my computer. This is something that I want to ship for the users to start using. So in a rough fashion, this is how you start. Data storage is always from data from different sources, collect, transform, and normalize. This is a process. Then later on, you still build a code, model for the code, deploy for the code. And it's a different story. Like you just go out there, figure out this is something that I want to do in my production. That means this is something that I want to deliver for some of the use cases that my business is asking, and that's it. It's still the same old thing. You just loop back, and this is where MLOps comes into the picture. So let me just not bore you with something which is like colloquial slides. Let me just open an LinkedIn post that I did. If you just go here and if you can see this, this is how an developer's aspiration turns into a production. That means developer's mindset, there are some favorite tools, train the model, there's a favorite language, a lot of other things. But later, you still go out there, figure out what should I package, how should I package, what are the parameters that I need to look back at. So if you look at Docker, it's dependencies, parameter, run scripts, build. And if you scale out, that means every little application that you have right now requires a lot of processing. So now to process the incoming traffic, there is a process that needs to be initialized. There's a tool that needs to be initialized in order to process the entire infrastructure. So this is where you see a lot of load balancers, data partition, and optimizations coming in. So in a bigger picture, if you go out there and figure out, okay, this is something that I want to do, and what should I be doing next? On a very bigger scale, it's just going to be like how much compute is required and how much is my traffic that I'm going to experience over a course of time. So let me not bore you with all these things and let me just show you this. So your ML code is from the NIPS paper. Whatever that you see is just about mimicking the brain and the way the information is getting transferred using neurons. It's still a math behind it. So there is a hardware device, there's a software device, and there's a math behind it. You're still optimizing it and everything. But if you look at how the entire process is, there's always a framing process of a business goal. There's always an access to prepare and validate data from the building models. Architecting ML solutions, that means you should know this is how much I'm going to code, this is how much I'm going to automate. This is the set of code that I might use for upgrading some of the packages, upgrading some of the things. And later on, you just go out there and figure out, okay, this is what I wanted, and it absolutely worked fine with me. And over a course of time, you don't stop there. Let's just go and deploy it out there, and let's just say that, hey, man, this is something that I want to do. Let me just push the entire repositories out there and let it start working. So either you iterate some of the processes as well. So during that process, you monitor, optimize, and maintain the performance of the ML application and the models as well. So what happens at the end of the day is machine learning engineering acts as an critical member of a data science team. That means there's data that's coming inside. There is a lot of things that you are just talking about. There are tasks which are researching about. There are tasks that you're building upon and designing for an artificial intelligence enabled application. So there's a lot beyond it. So I would love to end my slides with this one, where I'm saying about, hey man, there is data ops CI/CD platform that is still enabled with a lot of engineering as well as monitoring, as well as if you can see how, okay, this is how my system is. What you're seeing here is just the collection of features. So to the people who doesn't know, okay, this is what I'm having in my entire production line. It's very simple. You just have to go start your data operations, put in the CI/CD practices into it. That means continuous integration is a process to build your entire core. Continuous deployment is just a way in order to say that, hey man, you know what? We are going to make sure the amount of software that we have written gets used by hundreds and hundreds of people. And let's say your feature store is still going to be there, it's still going to be stored as an hash. So it's still the way you interact with the Git and the GitOps principle and a lot of other things that are coming up. So when the MLOps CI/CD solution is there, there are data scientists who are still monitoring the application in and out, interpreting the deployments, interpreting the way the application is getting deployed. That's a task. Optimizing the future processes that we are having, and the other thing is just work hard at the end of the day. So I think I'll just stop my share screen. I'll just have to go do a complete share screen so that we can go ahead with some demos. And I think let's do an entire share screen as well. Okay, let's just do window. I think that would be perfect. Let's do this. And I'll do an open. And I think I'm sharing my screen now. I hope this entire tab is visible for you right now. So if you can see that, okay, I have already made an brew install uh, Heart Labs or something like that. I don't have brew, I don't have Docker or anything, but I have Docker and everything. So let's just do one thing. Let me just go and run this application. And it obviously takes some time, but it's worth it if you can wait for it. So whatever I am showing right now, I just copied and put it on my entire application. So this one will be up and running. I'll just show it to you right away. So what's happening here is there is a process of annotating the data. And annotating data is something that is very far-fetched reality, right? You know for sure that somebody has to package the entire application and put it out there. So this is where tool like Docker comes in. Like I don't have pip installed, like I don't have a localized version of what do you call Python install or a brew installed on my MacBook. Or Git, of course, I could have done it, but it really takes a lot of steps. I don't want to go through that. So now I use Docker right now. So it's now getting used up, it's now getting built. So in a similar fashion, I'm just giving you an intro about how Docker is making an impact. And we'll go to one demo later on and we'll figure out, okay, this is what we wanted to build and this is the process that it's going through. So just go to Google and type in CVAT GitHub. It's computer vision annotation tooling. It's from Intel OpenCV project. The moment you start clicking on this application, you get to see that, hey man, there are hundreds of different applications that I need to build, but where can I really go back and look at, hey man, where to start and where to end? You need not have to worry about it. So what you have to do is very simple. You just have to do a Docker pre-built image and you'll obviously get it. All simple as that. Installation is also very simple. Installation, it's just Docker Compose up at the end of the day. So if you can see that there is something called as Docker Compose.yaml, and you can just go out there and start using Docker YAMLs right away. So this is how it makes your life much more easier and faster compared to other tools and technologies that we have in the market. So other tools and technologies might obviously give you a lot of headache, but this is something that is I've relied on over a course of time. So I think this is the end of one of the introduction that I wanted to give so that it doesn't make you feel that, hey man, we are just doing everything, but where is this technology used? So let me just share my entire screen so that you guys can start seeing everything. All right. Still needs help. Okay, I need to go to the system preferences. I will give it a try. And I use password. Again. I just came back. Sorry for that. Sorry for that technical glitch that I did. MacBook doesn't allow you to share your entire screen directly. So I think now I'm sharing my entire screen. It's time for us to go to some VS Code. So I already started applying some VS Code stuff here. So very simple. Don't worry about it. I think there is an model deploy. Okay. I think there was some requirements.txt issues that we had. Not a problem. So I just did it, right? I just did the Docker install. Everything is just now running. It's absolutely cool that this is how something that we started and this is how we are moving. So let me just do one thing. Instead of going to a lot of application, I'll just show you how easy it is to operate in Docker today. So you need not have to just get puzzled out on, hey man, we are doing this, we are doing that. Don't have to worry about it. You just can start your journey directly from Docker desktop. So let me just go here and figure out what's happening with Docker desktop. I need the Docker desktop to be up, but absolutely fine. If it doesn't come up because I think probably there's a compute issue or something. Not a problem. Okay. Wait. Uh, that's absolutely fine. Done. Docker. I just have to use Docker. All right. So let's not waste any more time and let me just start explaining what are these tools and technologies that we are working right now. So I think split to the right, close others. Let's not waste any more time. Let me just go to the file structure. So this is something that we wanted to do. And this is something that we wanted to put in our PyData application process and everything. So what we are starting to do is very simple. Uh, we are creating a repository of different applications. So each predicting everything is being taken care here. A lot of other applications are getting built. So this is one of the diabetes application. So I'll just do a quick intro about how to run this entire thing. So you can start with a new terminal and you can say Docker run Docker build -t slash. You can just type in model diabetes. And it's now just going out there and figuring out, oh, this is something that I wanted, and there's different issues that is coming up. So I'll do one thing. I'll not waste any more time. I'll just do Docker run -p 1000. Also, I can do 10,000 is to 80 model. And when I start running this, it's very simple. I just have to go to one query and I have to start it. So simple as that. You can still go out there and figure out, okay, this is something that I wanted to query. And it's just saying that, it's not 1,000, it's 10,000 right away. And there you have it. It's just saying that, okay, this is one application that you need and it started putting in. So now when I said that, hey man, I wanted to push out some queries and things saying, oh, it's not coming up. You know why? Because I have not put the query of 0.45. It's very simple. I'll just explain you how it is. These kind of codes are already available on many GitHub repositories and other stuff. So it's just simple. I just started using the Flask, Pandas, sklearn, all the other stuff. I started using a lot of diabetes pickle, read binaries. Yes, it initially puts in the binaries on this program here. And very simple, I started using an app write code and fast API started working. There's a lot of predictions that started coming in and pouring in. And there you go. You just started your own application. So simple as that. I just took some references as well, but I can show analytics with ya. So this is one of the blogs that I generally refer to if we are just going out there with some of the applications as well. So Okay, let's not. Okay, Jobathon. That's absolutely fine. Uh, I forgot the name of it, but I generally used one of the articles to mention to fast APIs as well. As I can show you in fast API, this one, fast API tutorials. So if you can go to the fast API tutorials, Tiangalo is one of those guys. These are the people who have used it. Ubicon main. Wait, I showed you right. It's all fast APIs today. So Ubicon is getting used and everything. So simple as that. What's happening here is you just do the pip install and everything, and simple as that. The next thing that you will be doing is you will be using some of these packages. You'll be using some of these base models and everything, and start putting in the application. And that is what I started doing. It's just simple querying stuff, and you are getting everything sorted by now. So float request arguments get. F is the argument that you're using, feature is the feature that you're putting in, and that is something that I put in here. So if you can just scroll down here. Okay, why it's not coming? It should actually zoom, but it's not zoom. But I can just show you here. So simple as that. What's happening here is I'm just able to query it. So I'll just copy it and I'll just show you how it's done. So what's happening here is very simple. Okay, wait. This can't be done. Okay, outline, timeline. Okay, something like this. But what we'll do is we'll just say that, hey man, the computer. This can be anything. This can be google.com as well, or something like anything. But I'm saying that, hey man, this is one of the queries, start predicting. And this is the value that I want to read. And this is the value that started getting read out there. So simple as that, once you start deploying, there's a lot that goes in, and that's it. You just get an access to the entire application within seconds. And I think that's the end of the session, folks. Is Docker just like how does the installation differ from Docker? Okay, normal installations obviously will take a lot of compute and everything, but you just have to just start working on it, and that's how it is. Is Docker just a virtual environment? Yes, I think uh, Informatics Bangalore chapter. Wait, I'll just give you one of the meetups that we have so that you can get it started. So normal installations are going to be much more tougher. Normal installations is something like, you have to make sure that your hardware is specific, the base OS, that means your MacBook or the Windows laptop has a version of Windows or the Mac version that is there. So there is a lot of dependencies that you have to do. So Docker makes it much more easier and faster to run on any VM as well. So let's say you have a VM which is like Linux, but you don't have anything. Install Docker onto it, or there is obviously an embedded Docker into it. Start working with it, and it makes much more easy and faster. Is Docker just like a virtual environment? I'm a newbie, so sorry for this question. Docker is just like a virtual environment, but what Docker does is instead of putting an hypervisor layer onto your VM, it just goes out there and figures out, okay, this is something that we want to put on our machine, and this is where you start working towards it. And that's it, simple as that. When can we actually use Docker compose.yaml? In the first application, there was multiple Docker compose files. Can you please tell why you need multiple Docker compose files? So multiple Docker compose files. I didn't write any Docker compose. It was just a simple demo that I just did from here and there. We are putting out an repository out for the PyData Bangalore. We are coming out with Docker and Kubernetes workshops as well. So it's one of the demos that I started working on. So Docker Compose is something like you have multiple applications, and how can you figure out to channelize using one command? Like let's say you have somewhere you have Redis cluster that is coming up. Somewhere you have something like Jupyter notebook application that has to be put in, and Redis has to start putting in the application. So I'll just go with the introduction to one of the things. So I'll just give you a quick intro so that you will start understanding. Okay, this is something that we wanted. OpenCV. So let me just share. I'm sharing a screen, so you can just show it to him so that he can start understanding. Okay, this is something is there. I think somebody has to just share the screen. All right. So he's sharing the screen now. So it just is simple as that. If you just look at this entire Docker compose.yaml, dev.yaml, ci.yaml, everything, what's happening here is just there is a lot of other process that has to be done, and we can't really figure out, okay, this is something that I want and everything. So there is a Docker compose.yaml. So if you can see that there is Redis cluster, the CVAT server that is coming up, which is doing is utilities that has to be put in. And these are the utilities which are running Django application. And Django is something that is phenomenal for any application. Let's say you want to upgrade to any new version of Django, so you can really do it right away. Else, it can be as good as Redis cluster has to be up, CVAT database, which is supposed to be sitting on your system, has to be up, and everything has to be much more easier. Docker Compose is just one command, and you can start working with it right away. So this is how it is. Let me just stop the share screen, and I'll just do one last demo for one DS environment. So Docker Compose is just going to be something like Docker Compose up, and you can do anything with it. So you need not have to worry about it. But I'll just show you a simple instance where one command prompt instance is just giving me so much of ease in the efforts that I should be putting. So simple as that. Let me just go here and do this one thing. Okay. Wait. Terminal, new terminal. So cd dev environment, dev env. So we can just go out there and figure out, okay, this is something we want. Wait, I did too much of it. Okay. cd dev environment. Okay, let's do one thing. Let's just push this to the environment here. So move terminal to the editor area so that you guys can start working towards it. Okay, there is already one application which is running, and I just have to control C. Clear. All right, I just cleared off all the application. I do cd dev env. So you can see that, I have put some dev build files here. So simple as that. I wanted to do a recent version of the Jupyter notebook and everything. But I'll just show you one thing. I'll just go to the Docker tutorial first. Uh, reactor file. I think that there is something called as a reactor file as well. Okay, sorry for that. Why is it? Oh, okay, sorry for that. So if you can go to one of the files, this is the GitHub repository that I have. You guys go and you can really go and learn GitHub actions, how the CI/CD pipelines are getting built. If you can navigate to this link, this is the PyData Bioinformatics Bangalore chapter that we have. You can look at how much of work that we are putting in with respect to bioinformatics as well. But I'll just give you one more link to the repositories. You can start learning about Docker, everything together. Don't worry about that. So yeah, I think don't worry about it. If Docker is just like it's still the same. I'll just show you some of the things here. And wait, was it this one? Okay, there's already running. Oh, this is localhost 8080. So if I just go here, I can start annotating the application. So you can see that, man, we directly had this entire application coming up to me right now. So I think Vishwas. There is label studio and every stuff. There is an lot of things that you can do. Okay, so probably there is an issue. Okay, I just don't have the keep me logged into the browser, but you can see that okay, the Docker Compose up is work absolutely running. Yeah, I'll just quit it off right now so that I don't have any other processes. So simple as that. I'll not waste any more time. I'll just go out there and do sh dev build.sh. You can see that there is already a build process that is getting initiated for me, and every process is already taking place right now for me. So if I have to go here, it's dev env, and if I do here 888, there's going to be dev env.sh. It's going to put in all the requirements for txt and everything to me right now. It's going to start working. So I'll do one thing. I'll not waste any more time. Docker images because we already have Docker. Yes. So this is one of the dive in. Vishwas Narayan slash Vishwas. Where is it? Docker PS minus A. Okay. So there are a lot of heartbreaks. Model two. There's a lot of things. I think I have to just go with the flow now. Let me not waste any more time. Okay, simple as that. Let's not waste any more time because there's going to be a lot of other things. So it's a simple thing. If you can go in the tutorial file as well, there's DSENV that I've created. So setting up a developer environment, everything from scratch, you can just start doing it right now. So Docker env conda. So I have installed a conda application. So what happens is very simple. So if you can go here and figure out, okay, this is something that I want. I took it from the same DSENV files itself. So what you have to just do is you just have to run this, and what you get is a Jupyter notebook interface here. Simple as a Jupyter notebook. What you get is still a Jupyter notebook. I think it's going to take some more time. If not, oh god, it's going to take a lot of time here. But we can just see what is that entire demo. This is something that environment will look like. So I go to 888. So this is how it will start looking. Of course, I've not opened 63 tabs, but one of the tabs, if you just open, this is how it looks. So I think that's it, folks. That's it from my side. I think if you have any doubts and queries, reach back to me on LinkedIn. If you want to contribute something on my GitHub pages as well, to go out there and check that out. So we will be happy to help you in any ways that is required in order to make sure. I think I've shared some link. Can you just go and put it in the chat there? I think I have to. I've shared some private links. Hello, Rohan.
Hi, Vishwas.
Can you share some of these links that I've shared in the repository, like the private chat?
um, yeah, give me a minute. Have you shared it with Tarun or how is it? Yeah,
No, no, I shared it in the private chat here.
yeah. Whatever you have shared is already come out.
Oh, yeah, like I just put it on LinkedIn. I just want you to go out there and put the same thing on this one as well. Yeah, that's the one. So I think that's it, folks. I just wanted to do a quick intro. I was not in the process of doing any other demos, but I just had to figure out a last minute demos, how to do it and what to do it, because this is going to be the beginning of it. I'm planning to do some more demos as well. So can you please share the repository link to mention for the tutorials? Yes, Docker tutorial files. That's a reactor file. That is something that we have learned, but Docker tutorial files is still there. So you can go out there and get that thing. I think that's it, folks. That's it from my side. Thank you so much. Let's catch up soon. Thank you so much, folks.
Yeah, thank you so much, Vishwa. This was a great session, and I'm pretty sure everybody found it very useful. And I
Sure.
also thank the audience for joining and exchanging questions and answers. Thank you so much, and we'll catch you in the other session probably next week. Thank you so much.
Sure, sure. Thank you so much.
There is a final question. Have you used Streamlit with Docker or Kubernetes?
So I didn't do much of a work with respect to that kind of an application, but if you ask me, Streamlit has a good support with respect to Docker. So it's just utilizing one Streamlit library that is put in the Docker hub, and you can start using any application out there. So it's as simple as that. You can start using that one application and do the same Streamlit up down also Streamlit run. I think I forgot the command of it, but you can still go ahead and still do the same application. So Streamlit with Docker is fine, but Kubernetes you can just deploy the same application with that's it. You don't have to worry about much of this thing. I think that's it, folks. That's it that we have. If you have any other doubts, queries, and questions, please do reach out to me on Twitter, on LinkedIn. I think the LinkedIn that they're showing is mine, so you guys can reach out to me on LinkedIn there. And I think that's it.
Yeah, awesome. I think that's all the questions that we have. And yeah, thank you so much, Vishwas, for taking the time and delivering this session. Um,
Sure. Thank you
yeah,
so much.
I'll probably end the broadcast now. Thank you.
Sure, sure.